Hello everyone, welcome to my channel. Today I will introduce you how to uh, implement the uh, si- singleton pattern in Python. Um, the first we need the singleton pattern because in sometimes our class was so heavy and we don't need it reload the data such as we in our project we have a configure dictionary configure module or class. It will collect many data from the database or local, and we want to um, if the parameter gets finished, we want it will repeat this motion. So we use the singleton pattern such as we only in mm, we only instantiate it once and not wrong not repeat this motion. So because this we need a singleton pattern. Uh, such as this class, we define this class. It have the init function. Uh, we in we create the instance twice, and it will run the init function twice, and uh, if there has many having code or run slowly code, maybe it will taken a large number of um, resource. We don't repeat this motion, so we need the singleton pattern. Mm. Okay, the next, how we implement it in Python. Python has a nature implement such as this. We define in the file A we define variable like named variable A, and it equal a list, and we define a file we create a file B and file C, and it all write this code. It import it, and we write the file D, and we call it, and through here we can see we use this line. Mm, okay, here has some error, red error. We get the variable ID. In Python, the variable ID is like the um, address in C++. Oh, okay, here. Oh, if we print this ID and print it in file D, import it in file D, it will execute the two line, and we can see the result. He will print the ID was similar, and because the Python will when we import it, it will not generate a new object. Okay, we can test it. We here we have the code. The file A only define a variable, and file B and file C it only have one line is imported and print the variable ID, and in file D we print both of them, B and C, and we can run it. Okay. Test 15. Okay, the basic. Okay, here we can see it will print the list object was same. So here the Python import the statement will not um, uh, 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 will not create the object repeatedly. So this is natural singleton pattern in Python. Okay, let's continue. And how the instance motion how the instantiate motion run. In Python class, we define two built-in function in here. This two function was new and init. Uh, as you have written the Python code, you will know the init function is used for uh, i- instantiate the value for the instance, and such as we give instance variable and mix a value to self member variable, and it will through this function give this value, and we all know this, but the new maybe you not familiar, uh, familiar because it's not used in basic programmer. Uh, the new function was used to tell the class how to create the instance, and there will call the super the parent class of new function. It will call the init function. We the Python programmer will through this function execute to there. So we define the two function to observe how it run. And here we can see the result. It will call the new function for at first, and then will call the init function. And uh, if we instantiate it twice, it will run it in twice. So um we have draw conclusion through this testing. Um and the is when we instantiation the class, the Python will run new function at first to generate the instance, and after it will run the init function to initialize the class, and the class variable the class variable is only generate once. Whatever instantiate how many times in there we define a value of class is class member is class variable. We give it a value of none, and in here we print the ID, and we can see here the ID was same. From here we can see no no matter we run the instantiate how many times this value um was constant. So from this we can we can design a singleton singleton pattern singleton pattern code. And let's we stop here and we try the code first. And okay, we can see the result in here. We define the class variable of class variable and it equal none, and we print the ID in here, and in the init function, and we can see the init function print the ID was same. So the class variable will not change when whatever we in 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 intention intentionate how many times, no matter we intentionate how many times. So let's say continue. Okay. The next was how to use this class member to um, intentionate intention in intentionate in intentionate and we define two value in there. It was class instance, and the class has a class initialized initialized and at the first we not have the class instance, so there was none, and we uh, will not have the class uh, initialized. So there we give a value of false, and when the function um, uh, uh, when when the class want to build instance, it will run the new function at first. So it will through this function, and there we will catch it if some class member of the class instance is none. We create a new, and we call them um, um, we call them parent new function to create this instance, and there we return the class instance, and in here we new it, and um, and assign assign to this variable, and there we return this, and continue the code will run at here. We we detect we not initialized the class, and we run once, and we assign this value of true to pro to prove this class is initialized. So we write code like this here. We can see the result. Um, at the first we intentional intentionalize intentionalize the class, and it will run the new function at first, and then it will call the init function, and when we run the twice, code in here, it will discover the class instance is not known. It will run in this branch, and return the value from we created at first. Mm, and in its function, uh, will discover it has initialized, so it will return. It will not run this code. It will run this time, and it print it. Okay, let's say test the code. Let's look it at first. So here, the result as our expect, and in sometimes our programmer was run in a high concrete scenario, and uh, maybe or the concrete was not so high, mm, but the function load programmer will run a lot of times. Maybe it will has some conflict. It will repeat this motion, such as we have two threads all ru- all run at this line, and it will run the new class at twice. Mm, So here we add the surrounding library. The surrounding library is in Python is used for to control the surround, and in here we use the lock feature, and the lock with mm, this function can auto realize the lock in there in whatever the whatever the error occur in there, it will release the lock after we run the code. And so here we can see it. At first um, um, we dr- we look at we look at does this we look up the class instance is null, and if we not create the class instance, and it will lock this block, and in this block we will and in this block, we will look up the value again, because in sometimes such as program not run finished, so we look at again. Um, Such as that scenario was when two strands all all run to here, and the next it will get the lock, and because such as the first third first third get the lock, and the second third will wait in here. Mm, so in here we should look up it again. So here we can see, mm, uh, we look up it again, and and then we uh, intentionalize intention and intentionalize it again, and return the instance class, and the same motion in the int function. It will protect protect the class int and the new function. It only run once, and the second was other way to implement it. We can see the code in here. Um, we only we we write a lot of code to implement this feature, but if we have many class want to use a singleton pattern, uh, and will uh, and the code will looks redundant. So here we have another way to implement it. Let's like the decorator. and we define a decorator like this. Okay. We not run this code, and here has class three. Okay, the code was run success, and it was we load the surrounding log. And other way to implement it, it was use a decorator. And in this decorator, we define a instance in it, and in there we was um get user class. We know the class was one um uh, in one progress only have one CLS object of the Python class. It's similar to the C++ um, global static variable, and it will only have once, uh, and we use it as a key. If this key not in the dictionary, and we will use it as a key to create a class, uh, and then we return this class. In the out layer, we will return the wrapper, and the code run as this. The code run as a director and decorator, and will to define this value, and it will return the wrapper, and then it will execute the wrapper, um and in the wrapper, we will check the CLS object does not have instance, whether it have the instance. If not have, we create it, and if not have, we create one. And in there we test it. We will see it. It will um create the instance only once. Here we run the code. Oh, yeah. The we intentionate it twice, but it only run once. So it is how to implement the Python singleton pattern, singleton pattern. And I will continue to share my um, experience or learning in this channel. How where if this video has some, if you interest this video, um, you can comment on the comment on this video. Thank you. Goodbye.